Good afternoon, ladies and gentlemen. Welcome to the Japan seminar, Challenges by Japan. Thank you for coming our seminar. I am Yugo Wakabayashi, Japan Ship Center, Jeto, London. I hope you are enjoying this wonderful maritime exhibition, No Shipping Here. So today, we would like to share the latest activity from Norway side and Japan maritime industry in this seminar. This seminar is organized by Japan Ship Exporters Association and supported by Nippon Foundation. The seminar themes GHG reduction measures for decarbonization, autonomous ships, alternative fuels, and so on. All of them are now hot topics, and I believe all you will find them interesting. I'm sure you will be satisfied with our seminar. Well, starting this seminar, we would like to have an opening remarks from Mr. Shunichi Miyanaga, President of the Japan Ship Exporters Association. We welcome Mr. Miyanaga, please.
Where the importance of the rule of law was reiterated and shared by the leaders. They gathered against an increasingly complex political and economic background, largely marked by the prolonged invasion of Ukraine by Russia, as well as the confrontation between the United States and China. Navigating this landscape is further complicated as emerging and development countries have been diversifying their approaches in today's more polarized world. In the midst of these changes, the way goods move in shipping industries will also evolve. With transformation of value chains and an acceleration of the energy transition, we'll see changes in the function of ships and technologies they employ. Ultimately, and more than ever, the role and importance of shipping in transportation as a whole are expected to increase. We, the shipping industry, support marine transportation through the supply of vessels, onboard equipment, and infrastructure. And although the environment surrounding us remains difficult, the earlier crisis situation has passed. Now, the industry is strengthening its ability to medium to long-term demand for the replacement of vessels that were ordered in large numbers in the past. In particular, in response to the early realization of carbon neutrality as confirmed by the G7, it is vital that we hasten the development of ships that use fuels, ships with electric propulsion systems, and ships that can meet the new transportation demands for products such as hydrogen and carbon dioxide. In this seminar, 6 Japanese companies and 1 organization, such as Nippon Shipyard NSY, Kawasaki Heavy Industries, Mitsubishi Shipbuilding, Tokyo Cake, Daihatsu Diesel, High-End, and Nippon Kaiji Kyokai (NK) will introduce their latest technologies and current initiatives. Furthermore, Norwegian industry associations, Innovation Norway and GCE Maritime Cleantech will make presentations on investment and opportunities for collaboration in Norway, as well as on the country's effort to decarbonize. These presentations will provide the latest findings and initiatives on topics of growing global interest in the shipping and shipbuilding sectors. I know that all of you in the audience are impacted by our industry, whether from the inside or out, and are therefore keen to gain insights and share views on these topics. I'm confident that you will find the content of today's presentations to be informative and provoking. I'm pleased to note that in addition to the participants joining in person here, the seminar will be streamlined live on YouTube through a digital platform developed by TFG. The digital platform can be accessed via the QR code attached to your program. Please enjoy the exhibitions prepared by our Japanese members in both real and virtual worlds. Finally, I'd like to conclude my remarks by sincerely wishing you all a meaningful and engaging seminar, and look forward to a successful conclusion to Norway Shipping 2023. Thank you very much for your attention.
Now, I'd like to move to the presentations. The seminar is divided into two parts with a 10-minute break in between. There will be total of 9 presentations from Norway side and Japan side, with time for questions after each presentation. Your questions and comments would be appreciated. For your information, the seminar scheduled to end at 4 o'clock. Therefore, we need to be efficient to run through the program on time. Please note that break may be shortened depending on progress. We would be appreciating your cooperation in this regard. So, let's start the first presentation. The first presenter is Mr. Naoki Herai from Nihon Shipyard. He will give you their current initiatives toward net zero with the title, Our Approach to Net Zero Society. Please welcome Mr. Herai.
Yugo-san, thank you for introducing me. Good afternoon, everyone. I'm Naoki Herai from Nihon Shipyard, UK. So I will introduce our approach to net zero society. So Nihon Shipyard, NSY, is a joint venture company established in 2021 between Imabari Shipbuilding, the largest shipbuilder in Japan, and Japan Marine United, the second largest shipbuilder in Japan. For your reference, the Nihon means Japan, same as Nippon. So And so please remember our company name and the meaning of Nippon, Nihon. So this is workflow. Nihon Shipyard work for sales, marketing, product development, basic design, and functional design. And then each shipyard work for production design, procurement, and construction. So in 2022, our new shipbuilding share in Japan is more than half, and it's about 10% in the world. So this is a shipyard location. We have 14 shipyards in Japan, and in Europe we have sales offices in UK and Greece. So Imabari and Japan Marine United built many kind of cargo ships. The main products, bulk carriers, range from Handymax to Newcastlemax and VLOC, and tankers range from MR to VLCC. The container carriers range from feeder to 24,000 TEU, and car carriers. And there are many others. So this is IMO greenhouse gas strategy in 2018. So I don't think I have to explain its details. But as you know, a higher target is being discussed in the IMO. So we have to build the vessels according to the international trend. So we can't discuss the net zero society without the carbon neutral and low carbon fuels. However, methanol and ammonia require significant time and cost to expand production and supply chain. Therefore, heavy fuel oil, include biofuel and LNG, will keep dominant until 2030. So this table is our fuel forecast to 2030. At least 2030, only some owners, the first movers, order the alternative fuel vessels, but the majority are going to choose the heavy fuel oil and dual fuel ready specification. So we will focus on developing better EEDI vessels using conventional fuels while developing dual fuel vessels to meet the market demand. It's our approach. So improving propulsion performance is always very important regardless of fuel used. So we have a lot of experience and know-how for many decades to improve ship's hull form and energy-saving devices. So these are our energy-saving devices. These devices improve energy efficiency, and we continue to improve and consider the combination of the devices. So in addition, we have been working on reducing additional resistance due to wind and waves for more than 20 years. So to reduce added resistance due to waves, we developed the most suitable bow shape for each occasion. So these are our original bow shapes. The ledge bow and SP bow are new type, and Axbow is slightly older type. So we confirmed the performance of Axbow. The speed loss in wave is clearly better than the ordinary bow. So this is one of our latest accommodation house. The round shapes of accommodation reduce additional wind resistance. So as I explained earlier, we are also developing alternative fuels vessels. For LNG, we are building the car carrier and Newcastle Max. And for methanol, so our group company, Minami Nippon Shipbuilding, built a methanol-fueled MR tanker in 2016. And recently, we are studying the methanol dual-fuel bulk carrier according to the customer's request. So for ammonia, Nihon Shipyard is developing ammonia dual-fuel vessels in 2 projects. So we are developing ammonia dual-fuel ammonia LPG carrier in Japan brand engine project. In this project, the Japan Engine Corporation is developing a main engine, and IHI Power Systems is developing the auxiliary engine. So in the other project, we are developing ammonia dual-fuel Newcastle Max bulk carrier. In this project, the MAN as a licensor and Mitsui E&S Machinery as a licensee are developing the main engine. So on the other hand, we started feasibility studies on several GHG reduction technologies. So there are not our own technologies. So we are studying through discussion with the manufacturers. So for example, we confirmed the installation availability and effect of the onboard carbon capture system for Suezmax tanker. So I will explain our monitoring system. The CNAVI is our cloud-based subscription service which provides a data monitoring and operation support integrated platform for voyage optimization and safety operation. We can also use the CNAVI data, monitoring data, to evaluate the GHG reduction technologies in actual sea. So we also implement other activities for net zero. One of them is liquefied CO2 carrier. So Mitsubishi Shipbuilding and Nihon Shipyard have started joint study for the development of an ocean-going LCO2 carrier. So this is summary. So please remember the Nihon Shipyard is a joint venture company between Imabari Shipbuilding and Japan Marine United. And please remember the meaning of Nihon. So this is our approach. We will focus on developing better EEDI vessels using conventional fuels while developing dual fuel vessels to meet the market demand. So that's all for my presentation. Thank you for listening.
Thank you, Mr. Helai. Now, I'd like to open the floor for questions. Raise your hands, and the staff will bring a microphone to you. Please give us your name and the company in the beginning of your comment. Now open the floor. Do you have any questions? So if there are no other questions, I'd like to move on next presentation. Thank you, Mr. Herai. So let's move to the next presentation. The next presenter is Mr. Luis Quadrante from Kawasaki Heavy Industries. He will give you the current development of the liquefied hydrogen carrier, which is the first development project of that carrier in the world, with the presentation titled Challenges to Carbon Neutral Kawasaki Liquefied Hydrogen Carrier. Please welcome Mr. Luis.
Good afternoon, everyone. Thank you for attending this presentation today, and thank you for your introduction. I'm Luis from the Kawasaki Heavy Industries office in UK. And today I would like to talk about our challenges to carbon neutral and about the development of our liquefied hydrogen carriers. My presentation is divided in 3 parts. Firstly, I will introduce our concepts for the international hydrogen supply chain. And then I will talk about the demonstration by a pilot project concluded in the beginning of 2022. And in the last part, I will explain our actions towards commercialization of hydrogen. Well, starting with the outline of the hydrogen supply chain. Well, this is a brief illustration of the international liquefied hydrogen supply chain. The key factors to achieve a hydrogen-based society are maintaining a stable supply of hydrogen and securing the affordability. So, hydrogen can be produced from diverse sources, including fossil fuel and also by renewable energy. Therefore, the international hydrogen supply chain can be structured with several countries around the world, as you can see in this illustration. In addition, we believe that by liquefying the hydrogen, it's possible to transport a large amount of it through large distance through using ships. Well, this is the concept of a CO2-free hydrogen supply chain, which was announced in 2010. The objective is to establish a stable supply of hydrogen while suppressing CO2 emissions in the process of production, transportation, storage, and utilization throughout the entire supply chain. Hydrogen is to be produced using renewable energy sources and also from fossil fuel paired with carbon capture storage systems in which all the CO2 produced is stored underground. Then the produced hydrogen is to be transported to Japan. Then the produced hydrogen is to be transported to Japan by liquefied hydrogen carriers and to finally reach the final consumers, which includes the power plants, transport, and industry. Moving to the next stop, I will show the demonstration pilot project finished in the beginning of 2022. This is the world's first hydrogen carrier that we have delivered in 2021. The vessel is named Swiss Frontier, which means the hydrogen frontier. This vessel has been built at the Kobe shipyard and has a vacuum-insulated cargo tank of 1,250 cubic meters. The cargo piping The cargo piping of this vessel is also vacuum insulated in order to maintain the temperature of the cargo during loading and unloading operations. The cargo handling system, composed by cargo machinery, shore connection, and vent mat, is also installed on board. So many novel technologies are fitted in this small hull. Here are some details about the cargo containment system. The temperature of liquefied hydrogen is very low at minus 253 degrees Celsius, and the latent heat of hydrogen is also very small. Therefore, a high-performance insulation system is required. To deal with this, the tank was designed with a double wall structure, as you can see here. This cargo is categorized as Type C by IGC code and is designed so the boil-off gas during the entire voyage can be fully accumulated. Well, regarding the material, the inner vessel of the tank is made of stainless steel, and the saddle support here is made of glass fiber reinforced plastics, which has excellent thermal insulation and also strength. With these specifications, we can suppress the heat ingress and make possible long-distance marine transportation of liquefied hydrogen. After construction of the ship, we have conducted several demonstration tests in 2 phases. In the first phase, the test of loading and unloading were carried out with liquefied hydrogen for the first time. Afterwards, the tests were conducted during a full load trial voyage in Japanese coastal waters. In the second phase, the technologies for long-haul transportation were tested while transporting liquefied hydrogen between Hastings, Australia, and Kobe, Japan, as you can see here. Through a series of demonstration tests, we successfully verified and validated for all aspects of the long-haul transportation, which includes the safety and the technologies used in this vessel. So moving on, in the last part of the presentation, I would like to explain our actions to the establishment of a commercial scale hydrogen supply chain. Now, we are proceeding with the hydrogen supply chain commercialization demonstration. It's a project supported by the Japanese government Green Innovation Fund. Its period is from 2021 to 2030. In this project, we will demonstrate a series of aspects of the international liquefied hydrogen supply chain, from manufacturing to transportation and storage of carbon-free hydrogen on a scale of several thousand tons per year. Our target is to achieve the first full-scale commercialization of hydrogen after 2030 and use it to show that the technologies to scale up are available, including the large-scale marine transportation with competitive costs. For the commercialization demonstration project, Port of Hastings in Australia and Kawasaki coastal area were selected. In addition, a MOU aiming to advance the establishment of a liquefied hydrogen supply chain between Japan and Australia was signed by major Japanese companies at the Asia Zero Emission Community on March 2023. And finally, we arrived to our large hydrogen carrier. This is a graphic image of the vessel under development. The vessel can transport about 106,000 cubic meters of liquefied hydrogen distributed in 4 cargo tanks. The propulsion system consists of hydrogen burning boilers and a steam turbine. Last year, we obtained the AIP for the initial design of this vessel. And this AIP shows that our initial design and its safety was verified by a third party, which is in this case was class NK. Here, I would like to introduce the novel technologies of the cargo containment system. This is a new cargo containment system developed with our own technology. It consists of a reliable spherical tank construction and has a double shell structure combined with insulation material. The insulation is the yellow around the tanks. Starting last year, we built a half-size tank in our Sakaide shipyard with about 25 meters in diameter, where we carry out the gas replacement, cool down, and hot up tests. Through these tests, we were able to establish the operational procedure for this newly developed cargo containment system and confirmed that the heat insulation performance can be achieved as planned. And another novel technologies in this are in the propulsion systems. The two major equipment of these propulsion systems are the hydrogen dual fuel boilers and the hydrogen dual fuel engines, the boiler and the engines. With the use of hydrogen as fuel, zero emission can be achieved. Regarding the boiler, the key component is a hydrogen burning burner for which the tests were completed in 2021. As for the engines, we are developing a hydrogen reciprocating engine for the electric power plant of this vessel. This engine will be installed on the large-scale ship for demonstration purposes. Both are core technologies developed by Kawasaki. In addition, we are sure that we can develop middle-sized liquefied carriers in accordance to the market needs. We are considering the possibility that in the early stages of commercialization, vessels with capacity ranging from 20,000 to 60,000 cubic meters will become the major size in the liquefied hydrogen market. These middle-sized carriers will be developed by fostering the technologies and expertise obtained through the development of Swiss Frontier, or small vessel, the large liquefied hydrogen carrier. These middle-sized carriers we believe our own wide range of technology will cover various sizes of cargo containment systems. We believe that an optional cargo containment system can be selected according to the project requirements by scaling up our small tanks or scaling down our large tanks, which are two existing and proven cargo containment systems. And here, to summarize my presentation, we believe that these are the keys to the future. First is the hydrogen supply chain. As I said, hydrogen can be produced around the world from a wide range of energy sources. And we believe that the liquefied hydrogen carrier is one of the key components to establish the supply chain because it can transport a large amount of hydrogen efficiently. The second key point of the presentation is Kawasaki is the pilot project. Kawasaki completely demonstrates long-distance marine transportation of liquefied hydrogen by its first ship, Swiss Frontier. Also, we demonstrate that the cargo handling system is functional, and we demonstrate the procedures for it during the loading and unloading operations. And the third point is the scale-up of the ship. We believe that the scale-up of the ship is essential to reduce hydrogen costs. A wide range of technologies will be available soon. A wide range of technologies to achieve the scale-up will be available soon. And we are sure that Kawasaki can provide various sizes of liquefied hydrogen carriers from the small size to the large size in accordance to the market's needs. So Kawasaki will use its own advanced technology to contribute to a carbon-neutral society. Well, that's all from my presentation. Thank you.
Thank you, Mr. Luis. So now I'd like to open the floor for questions. Are there any questions? Okay, so thank you for Mr. Luis. Thank you. So let's move to the third presentation. The next presenter is Mr. Shin Terada from Mitsubishi Shipbuilding. He will give you the current activity toward CO2 value chain, including the development of the liquefied CO2 carrier, with the presentation titled Initiatives for Decarbonization by CO2 Value Chain and LCO2 Carriers. You may know that CO2 value chain will be the key factor for the progress of decarbonization or carbon neutrality. Please welcome Mr. Terada.
Thank you for introduction, Mr. Wakabayashi. Good afternoon, everyone. I'm Shin Terada from Mitsubishi Shipbuilding, one of the group company of Mitsubishi Heavy Industry. Thank you very much for this opportunity to make presentation for our activities. I'd like to introduce our initiatives for decarbonization by CO2 value chain and the liquefied CO2 carriers. First, let me introduce MHI Group's initiatives. We call it Mission Net Zero. MHI has declared carbon neutral by 2040 and will promote energy transition, which consists of 3 pillars. That is, decarbonization of existing infrastructure, building of hydrogen solution ecosystem, and the building of CO2 solution ecosystem. Here, the CO2 value chain and the liquefied CO2 carrier I'm presenting today are part of CO2 solution ecosystem. In terms of reduction target for CO2 emission, we will contribute not only in scope 1 and 2, but also in scope 3. That means the emission of CO2 throughout the entire value chain. And we commit 50% reduction by 2030 and achieve net zero by 2040. This slide presents why CCUS is required to achieve carbon neutral. At present, it is said that approximately 40 billion tons of CO2 is emitted annually in the world. In order to achieve carbon neutral by 2050, emissions should be reduced by means of renewable energy, improvement of energy efficiency, the use of nuclear power, and so on. But we estimate that from 4.3 to 13 billion tons of CO2 emission will still remain, whose breakdown is shown in the pie chart in the right. CO2 emission from industrial field, fuel production, power generation, and other fields such as transportation are included. On the other hand, the amount of the current CO2 recovery is only 40 million tons, which is not balanced at all. In short, we suppose CO2 recovery by global CCUS value chain should be expanded from 100 to 300 times by 2050. Next, let me explain our idea for CCUS framework. We think one of the reasons why CO2 recovery is progressing slowly is that the destination of captured CO2 is limited. For this reason, we have begun effort to cover the entire value chain, not only for capture, but also for transportation or conversion. Let's say CCTUS, although T is not included generally, we address 3 frameworks for these 4 areas. The first one is contain. This framework covers capture and storage. In other words, it means method by which CO2 is not emitted into the atmosphere. Currently, our group has a global share of more than 70% in CO2 capture from flue gases, and we believe this is our strong point. The second one is connect. This means to connect each component in CO2 entire value chain in order to establish extensive and economical ecosystem. We think connect is very important to achieve the entire CO2 value chain, and liquefied CO2 carrier are included in this framework. The last one is convert. This is aiming to increase options for conversion in order to accelerate carbon neutrality. The captured CO2 can be used directly or converted to other variable resources. We have experiences of the systems for direct use, such as fertilizer production or enhanced oil recovery. In addition to these experiences, we are planning to enhance portfolio in this convert by investing in fuel synthesis or other startups. Okay, let's take a look at key components of CCUS value chain and the MHI group's contribution. Please look at the picture in lower part. This picture illustrates the entire CCUS value chain. The leftmost is the CO2 emitter, and next capture plant, liquefaction system, storage tank, transportation by ships, unloaded to tanks, compressor, and utilization. In this value chain, we can provide CO2 capture system, of course, also liquefaction plant partially, tanks and liquefied CO2 carriers. We can also provide compressors and utilization, such as fertilizer plants. As you can see, MHI Group can make a significant contribution in many areas in CCUS value chain. This slide presents solution for CCUS value chain we will provide by liquefied CO2 carriers. The first point is one-stop solution. Since we are now building a completely new value chain, it may not be the total optimization, even if the local solution can be made by ships. Here, as mentioned earlier, our group have many technologies which cover the entire value chain. We can develop liquefied CO2 carriers taking into account total optimization, such as compatibility to the conditions of captured CO2 gas on land. The second point is the development of large-scale, low-cost liquefied CO2 carriers. As I explained, very large amount of CO2 should be recovered to achieve carbon neutral. So we believe that demand for transportation by liquefied CO2 carrier will also increase remarkably in the near future. It means that much larger vessel will be required to establish a global CO2 transportation. Now, we are developing such large-scale liquefied CO2 carriers using our knowledge and technologies obtained through the experiences in building many liquefied gas carriers, such as LNG carriers or LPG carriers. Third point is development of multi-gas carrier for ammonia and liquefied CO2. As you know well, most of existing energy carriers, such as crude oil tankers, LNG carriers, LPG carriers, are laden only in one way, and they should return in ballasted condition. So we are focusing on the development of multi-gas carriers that can carry ammonia and liquefied CO2 in a round trip. This multi-gas carrier will optimize total economic efficiency of transportation and will provide wide flexibility in fleet management. Okay. Let me explain the technological development for large-scale liquefied CO2 carriers a little more. As stated before, Mitsubishi Shipbuilding has accumulated various advanced technology through the construction of many liquefied gas carriers. We believe these advanced technologies, such as numerical simulation, gas handling technology, or material evaluation technology, could be utilized effectively to resolve technical issues when large and economical liquefied CO2 carriers are developed. Here, the phase diagram of CO2 is shown at the top right. One of the major features required for the liquefied CO2 carrier is that the pressure should be kept high while the temperature must be kept low in order to transport CO2 in a liquid state. For this reason, due attention must be paid to possible phase transition of CO2 during operations such as loading, unloading, or transportation. We are now establishing appropriate CO2 handling procedure, predicting the phase transition by dynamic process simulations or various experiments. Another important technical issue is the structural design and material selection of cargo tanks suitable for characteristics of liquefied CO2, that is high pressure, low temperature, and high density. In this regard, we are making full use of our abundant technologies and know-how to address the issues on increasing the tank and lowering the cost of the tanks. In addition to our challenges introduced so far, Mitsubishi Shipbuilding has already started building an actual liquefied CO2 carrier for Japanese demonstration project of CO2 transportation. The vessel, which is currently under construction at our Shimonoseki shipyard, is scheduled for completion at the end of this year and will start transportation of liquefied CO2 from Kyoto to Hokkaido from 2024. We expect various knowledge and information will be obtained through this project that will be integrated into gas handling technologies for tomorrow's large-scale, low-cost transportation by liquefied CO2 carriers. In this slide, I'd like to introduce our activity on development of onboard CO2 capture system. As a joint project with Kawasaki Kisen and Class NK, onboard CO2 capture system was mounted on an actual vessel and demonstrated for the first time in the world in 2021. In this demonstration project, Mitsubishi Shipbuilding conducted a marinization of the system using our group's CO2 capture technology for land use. As a result of demonstration, CO2 capture function from ship's exhaust gas was confirmed to achieve prospective performance. Here is a list of news releases by us in connection with liquefied CO2 carriers in recent years. As you can see, we are working on joint development with various partners in the world. Particularly, we believe it is very important to collaborate not only with maritime industry, but also in cross industries, because we are in a phase of building quite a new value chain of CCUS that has never been seen before. So, we are actively collaborating with partners, including upstream industries, such as oil and gas companies, as shown in the list. Through such collaboration, we expect that our group's various CCUS technologies will be effectively utilized by partners and will make great contribution to enhance their business values. Lastly, let me introduce Mitsubishi Shipbuilding's future vision named Marine Future Stream. This is our vision for 2050, setting the goals of safe and secure future for society and decarbonization of the maritime economy. We will realize this vision by generating ideas for marine-related innovation through backcasting and bringing to life new technologies and services. The pamphlet of detail is available at Mitsubishi Shipbuilding booth, so we are very happy if you can see at our booth after this. This is all of my presentation. Thank you very much for kind attention.
Thank you, Mr. Terada. Now, I'd like to open the floor for questions. Are there any questions? If anyone has no questions, we would like to move on the next presentation. Thank you, Mr. Terada-san. So, let's move to the first presentation. The next presenter is Mr. Mikael Berg from Norwegian Embassy in Japan. He will give you the current activity of Norwegian maritime market, including the partnerships between Norway and Japan, with the presentation titled Overview of Norwegian Maritime Market and Japan, Norway Maritime Partnerships. You may know that Norway and Japan have fostered friendly relations for many years and cooperate in many sectors. Of course, we also work closely together in maritime sector. Please welcome Mr. Mikael Berg.
Thank you very much for the introduction. My name is Mikael Berg, Trade and Technology Office at the Norwegian Embassy in Tokyo. Thank you very much for the opportunity to present here today. Thank you very much to the organizers. I have been given a quite enormous task to give you a complete overview and details about all the partnerships. This I cannot do in 15 minutes. I hope to give you an idea of the backdrop of the situation and the regulations that will act as drivers, so you can understand why the Norwegian maritime sector is as it is. And I will also give a few words to encourage future and, of course, current partnerships between our maritime collaboration. As we know, the International Maritime Organization aims to reduce emissions from international shipping by 2050. And this goes for us all. So what can we do? I think we have to find ways to practically implement from ideas to solutions, from test and demonstration projects to commercially viable products. And that is not always easy. I am so impressed by the 2050 roadmap that you have towards net zero shipping in Japan for international shipping. And I'm very interested in following the Japanese companies and how you tackle the 2050 challenges. So the 2050, 2030 challenges, this is a shared challenge. And where there is common challenges, there should also be ample opportunity for more collaboration. So I'm thankful for the opportunity to give an overview of the maritime sector in Norway, together with some encouragement for future partnerships and collaboration on environmentally friendly technology and the maritime sector. So the ocean and ocean industries is very important for job creation in Norway as in Japan. And traditionally, the maritime industry has accounted for 30% of Norwegian export earnings. This is excluding oil and gas. More recent figures tells us that Norway's sixth largest export markets for maritime solutions, equipment and services is Japan, a very important market for Norway, not only because of the exports, because we have very many important and dear collaboration partners in Japan. An important market perhaps to mention to you today to understand the nature of the industry is to mention that it is a bit cyclic in its nature, as I will explain. So looking at our industry, it's obvious that the sector has and its activities has been closely linked to the oil and gas prices and the activity within oil and gas offshore. The keywords has always been change and adaptation to new market situations. And in 2014, we had a prolonged period with low oil prices in Norway, and the Norwegian shipbuilding industry had to quickly adapt to this new challenging market. So the ability to change and adapt and to apply our conventional knowledge to new sectors has been and is very important to the industry to keep skill and competence alive and developed. And as a result, we see that this knowledge today is being applied in adjacent sectors, such as offshore structures for aquaculture, and also offshore wind, offshore floating wind. And of course, this is very relevant for Japan today and going forward. You may know Norway as a nation that is in forefront of producing pioneer solutions. And you might know about world first projects such as Birkeland, Medström, Topeka, etc. I will not go into details on the technological solutions. I believe that Maritime Cleantech after me will give you an introduction to those. So please let me tell you more about the backdrop and the framework that supports the environment and ecosystem that produces these world first solutions. So Norway is a country with very high labor solutions. The labor costs is perhaps the highest among maritime economies, meaning other countries that also produce and have active maritime sector. So to be competitive, the Norwegian maritime sector needs to focus on high value added segments. This means that the competitiveness of our industry is based on knowledge and technology. And in other words, the main competitiveness in such a situation is upheld by conducting an immense investment into research and development. And the importance of innovation cannot be overlooked. And in the maritime clusters we have in Norway, which I call the innovation hotspot, you can find these, and you can also find ways to collaborate with these. Speaking of maritime clusters, here is an overview of the maritime-related ones. Most probably you can find many of them at the exhibition stands here today. If not the clusters, then at least the companies that represent the clusters. In Norway, you can find clusters, and they are kind of known by being complete maritime ecosystems that are also located quite close geographically. They have their unique focuses, and they have their administrations that help their members for joint activities and projects. And many, if not all, of the world first project has come out of these clusters. So in these clusters, you can find ship owners, brokers, insurance and financial services, classification institutions, shipyards, ship equipment manufacturers, maritime education, maritime research and development institutions, and a very comprehensive aquaculture ecosystem, maritime authorities, and so more. If any one of you have ever visited their web pages, you can see that their members are not only Norwegian companies, they are quite international. And this is the open approach for international collaboration for innovation. Now about you that are also eager to export products to Norway. How about the Norwegian registered vessels? And these are numbers I pulled out from the Statistics Norway database for 2022. On the left, you can see that the total vessels in the Norwegian merchant fleet is almost 1,600 vessels. And this is based on both registries, the ordinary ship registered and the Norwegian International Ship Register. To the right, you find also, for you to study perhaps after the seminar, I believe the presentations will be shared. Also the number of ships that are not in the merchant fleet as well. Typically you will find smaller vessels such as fishing vessels, specialized vessels, and support vessels. So how about the opportunities for increased turnover, value creation, and employment in a market of zero-emission vessels? Numbers from March last year show that around 23% of the Norwegian fleet was low-emission vessels and 1% zero-emission vessels. In comparison, only 4.5% of the vessels around the world were low-emission vessels and 0.1% were zero-emission vessels. And this graph shows you the share of low and zero-emission vessels built in Norwegian shipyards. You see the red dot is the percentage of low emission on the left axis. About 60% of vessels are low emission today, and about 2.5%, 2.8% of the vessels built in Norway are zero emission vessels. And the fact that Norwegian shipyards are leading the way in this field is a great advantage for us, because we know there will be a market for these kinds of vessels in the future as well. And very importantly, in Norway, the Norwegian Ship Owners Association has stated that they also aim to order only zero-emission vessels from 2030 and become climate neutral by 2050. So very short about the framework that we have to operate in Norway, and I like to call them drivers for change. And all markets have change drivers that speed up change. We see that the government ambitions in Norway, they are also paired with government support. When the policymakers set ambitious regulations that stimulate and also stipulate environmentally friendly ship use, not only the piloting and testing, but also commercial implementation in the maritime transport infrastructure, we see that in Norway, regulations can actually stimulate innovation. The example I will use is the environmental requirements in the ferry tenders in Norway, and that has been a very strong driver in the Norwegian market. In the ongoing green transition, we have many chicken and egg situations. Let us take one example from the onshore power infrastructure support for electric vessels. So the phasing in, or the ambition for phasing in electrically powered ferries and speedboats has been a key part of Norwegian government's ambitions and goals for fossil-free public transportation by 2025, and also halving the emissions from domestic shipping by 2030. So how are they doing it? There is a requirement of low or zero emission solutions for ferry and speedboat services in the national and county transport service network. There is public support for the development of electrically powered ferries and speedboats. There is support for establishment of dedicated charging facilities and ferry and boat routes. And of course, similar schemes for shore power, where support can be applied for investments in infrastructure, pre-projects, and also vessel conversion. It is Enova, Research Council, and Innovation Norway that has been founding agencies in Norway for this. You see, since between 2019 and 2021, the number of charging stations for ferries has increased fourfold in Norway, and in the same period, the number of shore-to-sea charging stations has increased from 92 to 170 or 177. Now the question remains, how can we do more in a larger scale to accelerate this development and commercial implementation of climate-friendly technology in the maritime sector. And this is very important for the private sector, turning ideas into business. Well, for one, many of, if not most of the world's first projects in Norway are collaborative projects, with many also non-Norwegian brands and companies involved, as can be seen of the members of the clusters. And I believe that leading projects comes from selecting the best technology and the best partners. And I believe we have ample grounds also for finding good collaboration opportunity between Norwegian and Japanese companies as well. And as you may know, strengthening the maritime commercial relation between Norway and Japan, we have a framework for collaboration already in place. And this is an MOU, Memorandum of Understanding, between the Norwegian Ministry of Trade, Industries and Fisheries and the Japanese Ministry of Land, Infrastructure, Transport and Tourism from 2011. So this gives us a mission and signals to what we should do, and that is to support you in finding partners and collaboration. And of course, this is why we're honored for being able to interact with you here today. And we are thankful for the Japan Ship Exporters Association and other involved companies for creating this arena in the bilateral Norway-Japan dimension here today, where companies can share and meet each other and find new partners for tackling the same environmental challenges. And hopefully we can see a more Norway-Japan partnership in the future. You can get in touch with us also in Tokyo, where we are located, and we will do our best to facilitate contact between companies in Norway for you as well. But of course, we hope that you will take the opportunity at Norway Shipping to engage directly. Thank you very much for your attention.
Thank you, Mr. Mikalberg. Now, I'd like to open the floor for questions.
Yes, we are still open for questions. Thank you very much. Perhaps I've already used up my time. But I'm looking forward to talk with you in the break as well.
Okay, so let's move to the next presentation. Thank you, Mr. Mikalberg. Okay, so let's move to the fifth presentation. This is the last presentation of the first part. The next presenter is Mr. Jan Norbeck from GCE Maritime Clean Tech. He will give you the current initiatives toward zero emission with a presentation titled Pioneering Zero Emission Solutions for Shipping. Maritime Clean Tech is known as one of the world's most maritime commercial hubs. They use the Norwegian maritime expertise built up over generations as a springboard for developing energy-efficient and sustainable technologies in collaboration with their partners. Please welcome Mr. Jan Norbeck.
Thank you very much. So first of all, I have to say thank you for the invitation. It's quite an honor to be invited to the Japanese seminar, so we are thrilled about that. Is it just for me to push the buttons there? I need some help. The presentation modus. It's loading. It's not a problem. We are among friends, so that should be okay.
there's
We take a
technical issue.
yeah, we take a few minutes technical break. Oh, fantastic! Then we are on. Very good. So again, thank you very much for the invitation to this Japan seminar. So what I'm going to talk about is a little bit about the maritime cluster, maritime clean tech cluster, and also just give you a small sneak peek of the different project which is going on in Norway and also in Europe where we are involved. So first of all, this is our cluster with the cluster members, and also mentioned by Michael that it used to be 10, we started 10 years ago, and then it was only 10 members or partners, and today we are roughly 150. It used to be a West Coast cluster, then we started to be a national cluster, and now we even open for international partners, which we are letting in. The only criteria we need you to follow is that you have to be a part of the green shift. If you don't believe in the green shift, then this cluster is nothing for you to be a part of. And as you can see, as you were mentioning, Michael, we need to have this ecosystem, right? With the shipbuilders, with the equipment, service suppliers, ship owners, energy company, R&D, finance, ports, classification, public sector, yards, and so forth. That is what we need to have on board in order to have this solution we are aiming for. We cannot move any forward by doing it ourselves. So the eco cluster for us, it's quite important. And also, please, if you have some question during the presentation, don't hesitate to ask. I'm quite used to that, so that's fine by me. You have seen a lot of figures now. This is the figures in a different way, Michael, than you presented, but it still shows the same. It still shows the same, that roughly 5% of the labor force are involved in the maritime sector in Norway, and they are producing roughly 80% of the value creation. And also mention that we are the 5th biggest in the world. I think Japan is hardly, we are more or less on the same level, I think. But if you go to the in value, then we are the 5th. So we are a rather big player on the maritime market. And also what we see, you know, this figure 2.5 is the world's CO2 emissions. But in Norway, if you look at the Norwegian short sea shipping, that means the ferry, everything we do short sea, we are up to 10% of the CO2 emission in Norway as a whole. So here is possibility to cut reduction, and that is what we are aiming for. And also, if you look at the goals, IMO set by 2030 that you should cut 30%. There are ambition in Norway that we should manage 50% of the reduction. So we aim to be a little bit better than the rest of the world. At least that's our ambition. So this is quite chaos, right? It's trying to be some kind of illustrative. So if you are a ship owner or operator looking into the future, this is probably how it looked like. It's trying to be, this is what we have to look at. We have today the LNG, the scrubber, the marine gas oil. You are familiar with the EEXI index. Could it be EED? You can also look at ammonia, hydrogen, batteries. All the different shipping segments, they have different challenges. So you cannot just say that you have one solution because it has to do with operation profile. Some vessels are going short, some vessels are going long, some vessels are going just from one port to another, some are going around the world. So you have to find the best way going ahead. Can I just put this one, how do I move the slides? Maybe I was so nervous that I dropped it. I don't know. It's working now. Yeah, but I can still start. So this is the way that the ship owners have to look ahead. This is the challenge now, and that is where we need to collaborate. Is it possible to change? Can you help me to change the? Yeah. So this is just another, maybe that should be me, I don't know. So again, if you are doing this yourself, this is the challenge you see. And if you are doing it yourself, it will be some kind of overwhelming. So what we really try to do in the clusters is to have collaboration. So Maritime Cleantech and the cluster, we see ourselves as an innovation arena or facilitators for our members. So if they have some very good concept ideas, we bring them forward into this different arena. We discuss it with the partners which are interesting in the different areas. So we have offshore wind, emission-free fjords, retrofit solution, deep sea logistics, and so forth. But the key word, I think that is the key word for at least Maritime Cleantech, is that we have had collaboration. Without collaboration, we are not able to move forward. So again, I will just give you, this is again a sneak peek of the different projects we have done the last 10 years. And as you can see, we have tried for the different shipping segment with different solutions for the energy carriers, like batteries, ammonia, hydrogen, wind, and so forth. Because there are different solutions for different shipping segments. Michael was also mentioned that when the Norwegian governments, they have ambitions to manage something. So then you are able to have something called soft funding from the Norwegian funding scheme. So ship owners like Norway and the companies involved here, if you are interested to do this green shift transmission, you are able to get some part of the funding, not 100%, but some part of the funding will be funded by the government. And what we did normally in Norway is that we take the low-hanging fruit, and the low-hanging fruit will be the passenger traffic. And then we have on the European scale, so this is EU-funded project. That means that you can not only participate or have a consortium with Norwegian partners, but you need to have at least 2 or 3 European partners in EU projects. And so far, in the Maritime Cleantech cluster, we have different EU projects going on. So the first one here is the Thon project. That's the Medstrøm. That's a passenger ferry. It's the first zero-emission fast ferry actually operating today. So it's really on the water operating today. Then we have in the River Seine, and we have 2 commercial operated hydrogen fuel vessels. So they are old barges retrofitted for the purpose to see if that is working. Then we have I think it's a really cool project. So it's Oslo Horizon, that's the world's first wind-powered ro-ro vessel. So it's Wallenius Wilhelmsen going from Asia to Europe with Volvo cars, see if it's possible to go by wind. So that depends to see. And then we have the last, next one is the ship Ahoy. And that's a scalable green and sustainable technology for power and heat generation on board ships. And the last one, I think then I will give that's called Ship FC, and that's the world's first high-power ammonia fuel cell on a vessel. And today I see that I have one of the partners in this Horizon Europe project, so I want to invite him. They are also part of this maritime cluster, so he can tell us a little bit about Ship FC, probably the company called Alma, and also how he thinks we are working in the maritime cleantech cluster. So Torleif Stokke, the floor is yours. You probably don't need this one, but I drop it, so I think I put it here.
My name is Torleif Stokke. I'm working in Alma Clean Power, a company which aiming to solve the problem for deep sea shipping and zero emission. And how are we going to do that? We are going to do that by developing solid oxide fuel cells, which has very high energy efficiency. It can operate on multiple fuels, and it has it was very interesting learning about the CO2 capture initiative, because capturing CO2 from fuel cells is much less energy consuming from or compared to the ICE technology which is there today. But this project is aiming to demonstrate a zero-emission operation based on fuel cells and based on ammonia as a fuel. So it's the solid oxide fuel cell which will be installed on board in Viking Energy, a 2 megawatt fuel cell, which is rather bold since the industry is in a very early stage. But nevertheless, we are going down that road and aiming to solve it. And this we could not do alone as one company. Then it's the collaboration, the project where we can find partners in maritime cleantech. So together we can lift such projects. Because we find the competence, we can also find financing to reduce the risk of the project within EU or in the Norway soft funding scheme. I think that's almost my time is over. I'm soon finished. Just a small invitation, because I have been working in companies, in small and medium-sized companies, which actually was one of the partners who formed Maritime Cleantech. And what do you get back to work in together with other partners? It's like mathematics that the children doesn't understand. It's you get 2 plus 2 is 5. So you get more back than you invest. And that's the beauty of working together, sharing knowledge and getting knowledge together. And by that we can lift such a project. We could not do that alone. Thank you.
Thank you, Mr. Mikael Berg and Mr.
Stokke.
Okay.
Yeah.
Okay, so now I'd like to open the floor for questions.
I knew there will be no questions, so I was thinking I will ask you a question now. When I saw the presentation given by Kawasaki, Mitsubishi, and Norway, do you see the similarity what we have done in Norway and you are doing in Japan? Do you see there's possibility to collaborate together? You are doing the same. You're looking at the value chain, you are looking at the scale-up, you're looking at the pilots, and so forth. So again, same as you are saying, Torleif, I think we should open up for collaboration, because I think together with you, with all your knowledge, bring that to the table, even though you're a so-called competitor. Instead of fighting for the same cake, I think we can make the cake bigger, because there will be more than for everybody to do. Do everybody see that during the presentation, that here is a great possibilities to do that? Yeah.
Okay, thank you, Jan Norway.
Thank you. Yeah.
I'd like to have a break for a few minutes. Please come back to the sheet by 3:05. Thank you. Welcome back to our seminar. I hope you had a lovely coffee break. Well, I'd like to start the second part of the seminar. So let's start the sixth presentation. The next presenter is Mr. Daisuke Maeda from Tokyo Keiki. He will give you an offer of solutions for the environment that can be implemented now, whether for existing or new vessels, with the title Safe Navigation Solution. Please welcome Mr. Maeda.
Yeah. Thank you very much. Thank you very much. I'm very appreciated for this great opportunity today. I'd like to introduce several solutions from Tokyo Keiki you can do now. Okay, before going to that, I'd like to introduce Tokyo Keiki because maybe you know, maybe you not know our company name. So first, introduction of the Tokyo Keiki, then I would like to bring other issues, two issues. First issue, introduction of Tokyo Keiki. We are established in 127 years ago, the first manufacturer in Japan of the radar, gyro compass, ECS, are kind of similar with the ECDIS or autopilot. Then the first gyro compass was shipped out more than 100 years ago. Maybe my grandfather is still not born yet. Okay. Then this is our company, and we are doing some jobs for the ECDIS and autopilot. Here, first, I would like to introduce about the ECDIS. ECDIS. Here, I have one question with you. According to the requirement or regulation, I have two questions now. Which is more important for navigation officer when you use ECDIS on board? First choice, COC, certificate, or familiarizing of the operation itself. Raise your hand if you think COC is important than familiarization. No one? No? Raise your hand if you think familiarizing of the operation about ECDIS operation. Oh, yeah. Thank you very much. Yeah, answer. I'm noisy, maybe? Yeah, actually familiarizing of the operation about the ECDIS on board. This is because, for example, STCW is clearly mentioned, seafarers are not required to provide documentation of the ECDIS itself. However, on the other hand, seafarers are required to familiarize with ECDIS equipment installed on board. You have to be able to use the ECDIS clearly and smoothly. So for example, here I bring some documentation from MAIB in the UK. There, one of the accident report clearly mentioned deck officers are unable to safely navigate using the vessel equipment. Accident happened by unfamiliarized officer. And the MAIB is open for their documentation for this kind of accident. Actually, what's the background? You can see this website, and they are freely open up to use this kind of documentation. Okay, so when you come to us, Tokyo Keiki, what we can do? We start to promote our new ECDIS from last year. Then it is including tutorial movies in the ECDIS itself. Also, in case of the port state control officer will come to your vessel to show the certificate, this ECDIS can issue COC on itself. This is COC, but you have to watch all movies, 13 or 14 movies. You have to watch. Then you don't, certificate will be issued. And this system is certified by Class NK. So this is good to use. You can watch movie many times, and you can make yourself to familiarize with ECDIS. This is ECDIS, and then next following, maybe we understand we have to save the energy. So this is another option from Tokyo Cake from autopilot side. Ace. Next question. Is there any active or former deck officer here? No? Okay. If your vessel is having 10 knots wind from 10 o'clock aside of your vessel, alternatively, how will you command or steer the vessel? How will you bring your vessel? In general, I guess the vessel is go to this side without any operation. Then the cursor will change its heading to put the vessel back to the original course. This is traditional way. However, this is a waste of the distance, waste of the fuel, waste of the time. Again, this is traditional operation. Once the vessel is going to a side of the course, officer will change its heading to put back the vessel to original course. However, we have new function. You put the arrival positions heading. This autopilot function will calculate ship's heading and rudder angle, bring the vessel straightly, go to the destination. But concern, we have concern. If the function, this function is difficult to use, I guess the cursor will not use this function because it is too complex. Or if it is not really efficient to use, of course no one will use. Must be able to simple and efficiency. So here I bring one movies here to show how it is easy. Now we are using traditional function, heading control. Just bring the vessel, like a white vessel in the previous slide. But if you go this one, just press this button. You can enter to next this advantage mode, S mode. Then you push this button again, put back to original. If your deck officer can use iPhone, Galaxy, smartphone, I guess they can use this function very simply. Then efficiency, concern, next concern, efficiency. We just got in last year from BV, Bureau Veritas, performance test of the energy reduction by this function. We got this attestation. If we got strong tidal current or ocean current, the fuel efficiency going higher. And this function, it is possible to install for your vessel now if Tokyo Keiki Autopilot is on board. But you think, it's really? It's just calculation. So we did actual ship test. This is the result. Bulk carrier, 1.47%. We compare 2 hours, traditional and new function. One officer changing over the function, then overall about 1% to 1.5% fuel saving was confirmed for all vessels. Actually, this is a graph, but I would like to bring the cross-track distance, which means the distance between original route to the actual ship's position. For example, XTD in a bulk carrier going to 1/10. Then operation itself is going to 1/6 or more or less. Same manner for other vessels, XTD going to 1/20, or same manner for the change operation itself, we reduce VLCC as well. So if we just calculate the bunker oil as a $420, actually now more higher, you can save this amount in a year. But just using this function. Okay, this is my slide. Thank you very much for your attention, and we hope you have a still safety voyage. And if you prefer to watch movies or something, here is QR code. Thank you very much.
Thank you, Mr. Maeda. Now, I would like to open the floor for questions. Are there any questions? Okay, we would like to move on to the next presentation. Thank you, Mr. Maeda. So let's move to the seventh presentation. The next presenter is Mr. Masaru Ochi from Daihatsu Diesel. He will give you regarding the GHG reduction measures for decarbonization with a presentation titled Development of GHG Reduction Technology. Please welcome Mr. Ochi.
Yes. Okay. Thank you very much for giving us your valuable time today. I'm Ochi from Daihatsu Diesel. We will now explain Daihatsu Diesel initiative under the theme, Creating Tomorrow with Daihatsu Diesel. Please listen attentively. Today, we will cover the following topics. First, introduction of Daihatsu Diesel. Second, domestic base in Japan. Third, introduction of the new factory. And then, LNG technology. Finally, new fuel to reduce GHG. What is Daihatsu Diesel? Daihatsu Diesel is a subsidiary of Toyota Motors Corporation. Founded in 1907, we now have a history of 115 years. We have been supporting the maritime logistics industry through manufacturing engines for ships, including large commercial vessels, tankers, and cargo ships. Daihatsu Diesel has 3 main bases in Japan. The head office is Osaka. And the engine manufacturing bases are located in Moriyama and Himeji. Regarding Himeji factory, we started its operation in 2018, which serves an advanced facility to meet the demand for larger marine engines. Next, let us introduce the market share of Daihatsu diesel power generator, large ocean-going vessels. We hold a 48% share in Japan and a 24% share internationally. Next, let us introduce, in 2018, we constructed a Himeji factory to meet the goal of enhancing marine engines and adapting to new fuels. It is a new factory with a different concept compared to our previous facilities. Himeji factory has test benches where can simultaneously test as many as 10 gensets for mega container ships. These test benches are also capable of testing with natural gas fuel. Himeji factory has its exclusive berth, which enable direct loading onto the ship for maritime transportation.
engines are placed on self-propelled transport vehicle and transported to the berth after their test running. Crawler crane installed on the berth lifts the engine to load onto the ship. This delivery process does not require disassembling engine, and it contributes to maintain the quality of the engine. We regard it as an urgent challenge in the maritime industry to address the global warming. We are marketing efforts to reduce carbon dioxide emissions from engines. Daihatsu Diesel has manufactured numerous engines of various output, which have been chosen and operated by our loyal customers based on reliable and high-performance diesel engine. We have been developing natural gas-powered engines. As natural gas-powered engine, we have delivered DE-28DF engines for JAXA, Japan Reading Space Center, for land-based power generators, and for large LNG fuel PCC. We are currently delivering DE-35DF engine for mega container ship, and DE-20DF and DE-23DF engine for large bulk carriers. We have delivered over 40 DF engines so far and have received orders for approximately 100 DF engines. We are also working on reducing methane slip, which affects our greenhouse gas. At the next stage of developing LNG-powered engine, we are marketing efforts to achieve zero carbon dioxide emission from our engines. As a part of GHG0 initiative, we have installed a single-cylinder test engine in our company for conducting combustion research on new fuels. We are also actively engaged in collaborative research with worldwide research institutions and universities. Here is a roadmap for future fuel compatibility. We aim to deliver our first commercial methanol-powered engine by the end of 2025. For ammonia, we have targeting commercialization in the late 2020s. Due to safety consideration against the toxicity of ammonia, we plan to construct a new independent and isolated building within our Himeji factory. However, as this will take several years, the development timeline is delayed if there is a need for ammonia engine by the mid-2020s. We will address it through the READY program. Regarding hydrogen, we have been conducting research with subsidy from Ministry of Land Infrastructure, Transport and Tourism from 2021 to the end of 2023. After 2024, we will continue our research independently. In the 2021 to 2022, we focused on basic research in collaboration with university, and in the 2023, we will conduct more detailed hydrogen combustion tests using our single-cylinder test engine. Toyota has introduced Mirai, a vehicle equipped with hydrogen fuel cell technology, into the market. We, Daihatsu, as a member of the Toyota Group, are also conducting research and development to develop fuel cells technology to the maritime use. Mirai means future in Japan, and together with Mirai, we aim to create a future. Furthermore, we are actively developing digital support through the utilization of artificial intelligence, AI. We are enhancing the engine conducting monitoring technology and advancing predictive and diagnostic technique to provide new maintenance support. Daihatsu Diesel aim to become a manufacturer that supports the future toward zero emission by 2050. That concludes our presentation. Thank you for your attention. You look forward to welcoming you at the Daihatsu Diesel booth. Thank you very much.
Thank you, Mr. Ochi.
Yeah.
Now, I'd like to open the floor for questions. If there are no any questions, I'd like to move on next presentation. Thank you, Mr. Ochi.
Thank you very much.
So let's move to the eighth presentation. The next presenter is Masanori Higashida and Mr. Yoshinori Fukui from High-End. They will give you the efficiency solving common challenges for hydrogen with the presentation titled New Challenges to Development of Marine Hydrogen Fuel Engines. Please welcome Mr. Higashida and Mr. Fukui.
Thank you for introduction. So, new challenge to development of marine hydrogen fueled engine by joint venture presented by High-End Corporation, Masanori Higashida and Yoshinori Fukui. To achieve carbon neutral in 2050, fuel conversion is absolutely essential to significantly reduce GHG emission. Hydrogen fuel is regarded as promising a carbon-free fuel, but hydrogen-fueled engine for large ocean-going or domestic vessels are not widely available at the moment. We have common challenges to development of hydrogen-fueled engine, such as hydrogen embrittlement, abnormal combustion by hydrogen fuel supply system, and compliance to the international rule. To solve the common challenges for hydrogen, we decided to establish the consortium by Japanese engine manufacturers. So this is organization chart of R&D. We, Kawasaki, is developing a middle-speed four-stroke hydrogen-fueled engine for propulsion. We have a plan to carry out the service test on the hydrogen carrier, which will be built by Kawasaki. And Yamaha is also developing the middle and high-speed four-stroke engine for generator. Then the Yamaha has a plan to carry out the service test on the domestic oil tanker. Japan Engine is also developing a low-speed two-stroke hydrogen-fueled engine for propulsion. Japan Engine has a plan to carry out the service test on the 70.5 thousand deadweight ton bulk carrier. Kawasaki is also developing the fuel supply system with a liquefied hydrogen fuel tank. Kawasaki will provide a small size MHFS to a Yamaha project, and Kawasaki will provide a large MHFS to Japan Engine project. We carry out the risk analysis with class NK, and the result of the risk assessment will be based on the guideline and rule for hydrogen fueled engine. This national project is supported by a Green Innovation Fund. To boost development efficiently, we decided to establish the combined investment joint venture company, High Engine Corporation. Kawasaki and Yanmar and Japan Engine has already set up the combined investment joint venture for developing of hydrogen-fueled engine. Target of JV is to play the role as a development center of the hydrogen-fueled engine. So here you can see the common test facility managed by High Engine Corporation. One common hydrogen supply facility can supply hydrogen gas from the liquefied hydrogen tank to each hydrogen-fueled engine. This fuel supply system is just now under construction. So one of the most important technical challenge is hydrogen embrittlement. To evaluate the hydrogen embrittlement, we carry out the following three-step evaluation. The first step is selection of materials. From among engine parts, we'll pick up materials and usage environments that are concerned about the impact of hydrogen embrittlement. The second stage is the SSRT test. So SSRT is a slow strain rate technique. We will identify the environmentally highly susceptible to hydrogen embrittlement. If there is any doubt, the result of the SSRT, we proceed to the third fatigue test, third step. At the third fatigue test, we compare fatigue strength and the hydrogen environment and air. Then we can evaluate the effect of the hydrogen on the fatigue strength. One of the most difficult technical challenge is hydrogen combustion. There are many papers for automotive engines, basic knowledge, but marine hydrogen fuel engine by using dual fuel combustion and gas admission valve has several differences from the automotive engine basic knowledge. Therefore, two visualization tests were carried out to obtain the fact of hydrogen combustion. Left-hand side shows a dual fuel combustion test. Right-hand side, this is the air and hydrogen mixture formation test. So dual fuel combustion test we carry out in cooperation with Kyushu University. And mixture formation test we carry out in cooperation with Hiroshima University. Some of these tests are in progress, but will be completed soon. So from now, I can tell you current development status of Kawasaki. So this is a property difference between hydrogen and methane as fuel. One of the biggest development challenge for hydrogen engine is control of abnormal combustion, such as knocking, pre-ignition, and backfire caused by the physical properties of hydrogen. To avoid and control the combustion, abnormal combustion, the EGR, exhaust gas recirculation, is the effective measure. So EGR system is supplies a low oxygen fuel gas by partially recirculating the exhaust gas with low oxygen concentration after combustion. So previously, EGR is a well-known technology as a reduction of NOx reduction. But now we will apply EGR system to hydrogen engine. So advantage of EGR is promising a means of improving efficiency and increasing power output of engine. On the other hand, disadvantage of the EGR is a complicated system or will be a higher cost. So here you can see the overview of marine hydrogen fuel supply system, so-called MHFS. So left-hand side shows the small size MHFS to Yanmar project. The fuel is supplied by the pressure build-up in the tank by air heater. And this small size MHFS will be a container package. And verification test on board will start from 2027. Right-hand side shows the large scale of MHFS to Japan engine project. A fuel is supplied by liquefied hydrogen pump, and the delivery pressure is about 300 bar for high-pressure hydrogen fueled engine. And the tank capacity is approximately 200 cubic meter, and verification test on board will be in 2028. So from here, I can tell you current development status of Yanmar. So Yanmar is developing the two kinds of marine hydrogen fueled engine. One is a medium speed dual fuel type, and the other is a high speed spark ignition type. Full scale test engine is completed in 2026 and 2028. These engines are developing according to the process shown in the slide. Currently, the CFD model has been completed, and then the single cylinder test engine is now working as planned. And then the single cylinder test engine will be completed in March 2024. After that, move on to the full-scale test engine, full-scale engine test. So on behalf of the Japan engine, I can show you current development status of hydrogen-fueled engine of two-stroke engine. So brand name of Japan engine two-stroke is UE. So UE is a purely Japanese brand and is one of the three major brands in the world. So Japan engine is aiming to develop the first high-pressure two-stroke hydrogen-fueled engine. And Japan engine for the the first hydrogen-fueled engine bore size is 35 centimeter, and Japan engine is planning to expand the other bore size engine based on the market needs. As current development status, the rig test of high-pressure hydrogen fuel injection device has been started in the Japan engine factory. The trial of the hydrogen-fueled engine will be in 2026, and the vessel with the hydrogen-fueled engine is delivered in 2027. That's all my presentation. This project is supported by Japanese government, METI, EMRIT, and NEDO. Thank you for your kind attention.
Thank you, Mr. Higashida and Mr. Fukui. Now, I would like to open the floor for questions. Okay. There are no any questions. I'd like to move on next presentation. Thank you, Mr. Higashida and Mr. Fukui.
Thank you.
So let's move to the ninth presentation. The next presentation is the last one for today's seminar. The next presenter is Mr. Rikiya Kuranobu from Class NK. He will give you the mass which is under active development in many countries with the presentation titled Challenges of Class NK toward Mass Social Implementation. Please welcome Mr. Kuranobu.
I'm sorry, I can't move to the next slide. So. Oh, okay, thank you. Oh, thank you. Oh, okay. I see. Today, sorry. Can I? This is my top slide. This is not my top slide, so. Okay. I see. Okay, thank you so much. Hello, this is Rikiya Kuranobu. Thank you for coming to my presentation. I'm in charge of the safety evaluation for mass technology in Class NK. Today, I'm going to talk about the challenge of Class NK toward mass social implementation. This is today's agenda. At first, as an introduction, introduce the world situation around mass, and next, challenge of Class NK for mass, and then activity for mass in Class NK, and finally conclusion. First of all, I'd like to talk about what is mass. What do you imagine when you hear the mass? Is it unmanned navigation ship, or highly support ship for seafarers, or remotely maneuvering ships? Actually, the definition of mass is under discussion internationally, and this is because there are a lot of concepts at this timing. So in this presentation, I temporarily defined mass as ships that have transferred part or all of the tasks performed by seafarers on conventional ships to automated system or remote operations. As you may know, mass is developed for various types of ships in many countries, and mass for coastal area is majority. And this is social implementation of mass is aimed by 2025. NK is involved also ongoing demonstration test. On the other hand, it is necessary to develop not only the technologies, but also the rule for mass social implementation. Regarding international rule side, the draft of the goal-based mass code is developing. Just now, discussed in the MSC 107, and the draft of mandatory mass code will be finalized in 2025. So in Japan, mass is expected to enter the market by 2025. So rule side is also by 2025. I mean that it is so limited.
From this world trend, like technologies and rule development side, people consider the various concerns for safety in this society. These are some typical issues, like what kind of safety requirement should be considered for the recent technology, or what tests need to be carried out to the demonstration test for safety. Furthermore, is mass really safety or really reliable from public opinions? So this is because mass rule development and technology development proceed in parallel. So NK law is to challenge these issues. Specifically, this slide shows our challenge. NK is involved in the several ongoing demonstration projects and also involved in the from the concept to design stage. And NK also actively involved in the IMO and national regulation discussion. And towards social implementation, we need to consider the safety assessment framework for in design and the development phase, but also in the operation phase. So, NK believes that the role of the class is to resolve these information asymmetry between the technology and rule side. So we provide appropriate information to each side. In short, as for our certification activities, we review the safety as a third party at each development, especially from the concept to design stage. And we consider the safety assessment framework, including operation phase. And as for the rule development activities, we feedback our knowledge to accelerate discussion internationally. And finally, besides 2 points, the social acceptance, like the public opinion, is very important factor. So we relieved anxiety about unknown technologies through the informative activities. In order to deal with these challenges, we established a project team and have worked towards social implementation. Main activities, 4 points: certification, rule development, and informative activities, and research. Research is inclusive support of the other activities. In our previous certification activities, we would like to introduce the representative samples. In Japan, as you know, there is a big project. It called the Meguri project, and we involved in the risk assessment in this project. And also, we confirmed the feasibility of the concept of Apex Suit. Apex Suit is one of the Meguri projects jointly developed by the NYK Line, MTI Company Limited, and JMS Incorporated. And we also granted the AIP. AIP means the approval in principle. As for the rule development activities, we take part in the IX expert group, and we also issued our guideline for the automated autonomous operation of ships, and we also contribute to the flag state constellations. As for the informative activities for social implementation, we submit the paper to national and to international journals, and we also publish cross-indicate technical journal. And finally, the most recent activity is to publish the white paper. This is based on the finding from our activities, like the rule development, certification, and research. And we would like to provide NK's perspective for safety as a reference in discussion among the mass stakeholders. In this remaining presentation, we choose the essence from the white paper. And we brief explain this safety assessment framework for the mass design and development phase and the PDCA cycle for the operation phase. In design and development phase, as I mentioned, mass is expected to have the variety of the use cases. So it is necessary to consider what kind of technology are applied to requirements to each use case. So in order to build the consensus from this first step, so goal-based approach is recommended. And also mass is a very complex system, so need to conduct a lot of tests. So if we apply the conventional way, so the concept of the system engineering, like the V process, is very effective, so that it prevents from the reworking in verification tests and conduct tests efficiently. So in order to realize this concept, we propose to set the goal at first and apply to the concept of system engineering. Then we initially join from this first step, the concept stage, and confirm its upstreaming requirement and the test. Whereas in the operation phase, people consider the design and the implementation at this timing, but after the implementation, how about check and act? How do we monitor and how do we improve these technologies? It will be necessary to devise the actual operation method after realizing the imperfection of the technology, since novel technology are applied. So we propose a mechanism to name vulnerability database. It is for collecting data on defect and near-miss incident found after implementation to constantly update regulatory requirement and evaluation method. Totally, we propose this safety assessment framework in our white paper. Today, I introduced our challenges and our activity, especially our white paper. Through these activities, we would like to contribute to the realization of safe and secure mass for the bright future of maritime industry. Thank you so much.
Thank you, Mr. Kuranobu. Now, I would like to open the floor for questions. Are there any questions? Okay, so if you have any questions, please contact each presenter directly after this seminar. Thank you, Mr. Kuranobu.
Thank you very much.
So I'd like to finish up the presentation sessions. So we would now like to invite Mr. Shigeki Kinoshita, Chairman of the Japan Ship Machinery and Equipment Association, to give the closing remarks of the seminar. We welcome Mr. Kinoshita, please.
Thank you. Ladies and gentlemen, I'm Shigeki Kinoshita, the chairman of Ship Machinery and Equipment Association. Thank you for participating in today's seminar. Thank you, Mr. Mikael Bell, Mr. Jan Norbeck, and all presenters. Thank you very much. I think all presentations include a lot of important topics. As we mentioned in presentation today, Japan marine industry are working together with the government and private sector to decarbonize the country. Since today's introduction was brief, We hope that you will visit the Japan Pavilion during the shipping for a more in-depth exchange information. Finally, we hope you will visit the Sea Japan exhibition in Tokyo on April next year, where Japanese ship owners, shipbuilders, and marine equipment manufacturers will join together to promote the various initiatives and technical developments. We would be glad you can visit to Sea Japan exhibition. Thank you for participating in today's seminar. Thank you very much.
Mr. Kinoshita. So, how was this seminar? I hope you totally enjoyed it. Today, we have introduced the latest activities from Norway maritime sector and Japan maritime sector in this seminar. You may know the realization of autonomous ships and overcoming challenges toward decarbonization in international shipping sector would be inevitable. And all you are really interested in the new technology. Japan is exhibiting as the Japan Pavilion in Hall B as the Japan Ship Exporters Association in B0108, the Japan Ship Machinery and Equipment Association in B0208, and Class NK in B0114. Please stop at our pavilion and feel free the latest advanced technology at each booth. All right, it is time for closing. Thank you very much, all participants, for attending this seminar. Please give a big hand for all speakers. I hope to enjoy your stay in No Shipping and stay in Oslo. Thank you and see you next time.